Hello there, and welcome to the physics unit of grade 10. In this unit, we're going to be learning about the properties of light and how it works in different situations. And that study is called optics. So we have a couple sources of light here. We've got a sparkler, which is a chemical reaction that's given off light. It's very hot. You wouldn't want to put that on your face. Then we have this glow stick, also giving off light, but doesn't seem to be bothering a little boy with it on his face there. And of course, this is an old style incandescent light bulb, also pretty hot. You wouldn't want to put that near your face either. So obviously different ways of making light, and we're going to be looking at a few of those as we go along. So what is light? Well, it's something that everybody knows what it is, but it's very hard to describe. Scientifically, it is a form of energy, and it has electrical properties and magnetic properties, so we call it electromagnetism. A couple other properties of light is that it can travel through nothing, a vacuum. The sun is way out in space, 150 million kilometers away. And in order to get here, it has to travel through the emptiness of space. So that is a property of light. It goes very, very fast. It only takes about 8 minutes for light to travel the 150 million kilometers. And it always goes in straight lines. If you've ever had a flashlight or see light beams shining through the clouds or through through a smoky room, you might see that these beams are always in a straight line, and that's true as long as whatever it's passing through is the same throughout. So this would be some, vapory air, and the air is the same throughout, and so the light will travel in a straight line. So this electromagnetism that is light has a property that is a lot like a wave most times, which means that it can be like long, slow waves or short, really fast waves. And that makes a difference between the different types of light that we can observe. So we have radio waves that are electromagnetism. We have infrared waves that are electromagnetism. X-rays, gamma rays, they're all the same type of energy. There are differences in the wavelength and frequency of those waves. Wavelength is the distance between the peaks of a wave, like from here to here, and frequency is how many of them are going by in a given unit of time. Now you notice the center part here is the only part that our eyes can detect. So this visible spectrum, that's the part of the electromagnetic spectrum that our eyes can actually sense. And if we want to observe those other parts of the spectrum, we have to use other detectors. And so there are places, say telescopes that look up at space, and they only collect X-rays, they only collect radio waves, and they can observe different things from the light that's coming from space that our eyes cannot detect. So an interesting thing happens when light travels from one substance into another substance. So there's a fancy word for this. They call the different substances medium. So we have some air here, and the light's traveling along in a nice straight line. And then it hits this piece of glass, which is a different medium, and it changes direction. When it does that, it's going to slow down. And when it slows down, different frequencies of light or different energies of light will change direction different amounts. So the higher frequencies of light, the higher energy light, would be the violet here. And it changes direction the most. You can see it bends the most as it comes out of the prism. And then the lower energy light, the red, bends the least. And you can imagine the rest of the spectrum on either side, which are the parts of the light that our eyes don't detect. But they're all going to slow down different rates due to their frequency as they pass from one medium into another. So now let's look at sources of light. Where does light come from? Well, you got two options. One is objects that are making light or giving it off through some process, and we call those luminous objects. So all these little LED lights in the wintertime here are giving off their own light. And the other type of source would be non-luminous objects that can only reflect the light off of other sources, right? So behind the camera here, there must be, some car headlights that are shining on this sign, and what you're seeing reflected back at you is the light from the car. So luminous sources of light come from a variety of processes. Chemical reactions and nuclear reactions too, they give off light by exciting electrons. Electrons get bumped up from the heat to higher energy levels. And then when they fall back down to their original level, they're going to give off some light. And so since there's multiple electrons here and some of them are jumping different distances, well, you can get different colors of light due to those different jumps. So same with nuclear energy. Again, the heat that's given off by those nuclear changes causes electrons to bounce around and give off light. So really, really hot things can also give off light. A stove that has a chemical reaction inside giving off a lot of heat will cause the metal on the outside of that stove to glow if it's hot enough. Same thing with electricity. If it passes through the air, like with lightning or sparks, that can cause the atoms to give off light again and make that glow. So that's when things are really, really hot. Another source of light is when a substance will absorb one form of light and then re-emit it. So phosphorescence is when you have a chemical that'll soak up some light, like these D&D dice I have. And then if you turn off the lights, they'll glow for a while as they re-emit the light that they just absorbed. So that's phosphorescence. Fluorescence is when you have one form of light being converted into another form of light. Inside these bulbs, ultraviolet light is being given off, but we can't see ultraviolet light, but the coating on the outside of these tubes converts the ultraviolet light into the visible part of the spectrum of light so that we can see it. Another place where you see fluorescence is those highlighter pens, right? They convert some of the ultraviolet that's around us all the time into visible light, and that's why the pages seem to glow when you use your highlighter. So some chemical reactions can also give off light, but don't require heat like the fire or the electrical discharge. So chemiluminescence, that'd be the light from chemical reactions like the ones in those glow sticks, giving off light without giving off very much heat. Bioluminescence, that's when pretty much the same thing happens in a living thing like this little firefly here. And triboluminescence, which is one that I don't super well understand, and that is if you put some crystals under pressure, if you get like those wintergreen candies and crunch those between your teeth, sometimes you can see a little spark or light given off by the orientation of the atoms in the crystal, and I guess the reorganization when you crush them causes a little bit of energy to be released, and some of that would be the visible light. So finally, a really cool light source that's often used for experiments with light is a laser. Laser actually is an acronym, stands for Light Amplification by Stimulated Emission of Radiation. Anyway, so the difference between the light from a laser and the light from just a regular light bulb is that in a light bulb you have wavelengths of light that are all variable. You have some high energy ones and you have some low energy ones. And you're just going to get this combination go in every direction, every which way. But what you get out of a laser is this very coordinated, uniform set of light waves that are all the same. Now, it's going to be hard for me to draw. I should have made some animation for this. Anyways, you get the idea. They're all going the same direction. They all have the same wavelength, the same amount of energy. And that uniformity allows lasers to go long, long distances in a nice straight line because the energy is very focused and all going in one direction. All right, hope that helped. We'll see you soon.